Namaskaram everyone, welcome back to the 67th episode of Master Unreal series, and in this episode we are going to continue our shop system which we started in the last episode. So in the last one you created the smart object, you made the slots, you made the customer and the merchant components. Now in this one I'm going to show you how you can interact with these smart objects. So the target of this episode will be to send your customer to the shop. And if you haven't seen the previous episode, I highly recommend you do that because we have already set up the smart object. So without wasting any time, let's get started. Okay, so in the last episode, you placed the James character and we had this shop counter ready, and we have two components. One represents the quality of the character, that is the merchant, and second one is your shop counter, which is added in any kind of shop table. So these are the two actor component that we created. Now let's start. So when you place this shop in your level, you want to assign who are the merchants in this shop that will be managing the customers or the trade. So for this, we created the shop counter component, which will handle all the trade related functionalities or other things that are connected with this table. We want to keep our actor lightweight. So first of all, we will take who are the merchants, and through the level editor, we can only take the actors or the characters references. We cannot take their components, because if you check James, James has this merchant component. Now you cannot take the merchant component here. So I'll show you what I mean. I'll go to my shop counter, and under the public variables, I will say I want to store the merchants. So we will say it's a list of merchants, which means it's an array. Array of what? Merchant, or basically characters to be precise, which is an actor. So we say, okay, it's an array of actors, but actor is an object, a fully loaded with components, variables, functions, and everything, which means we are not taking the entire data, we will be taking the pointer. So, okay, you are going to take pointer. So what type of pointer are we taking? So we'll say we are taking weak object pointer. I'll come to this why I'm using weak object pointer here, but let's complete first. So we'll say it's a weak object pointer to the actor, and we are going to store the list of the actors, and we will say assigned merchants. All right, now let's expose this. This is a variable, so u property, and we will say edit anywhere, which means we will be able to edit in the editor or in the level editor. And we will give it a category, and we will say shop counter, or you can say shop component. That is also better. I mean, you can also name this shop component instead of shop counter, but it's okay. So let's hit the live coding again. Okay, now once you do that, so you will select this table. Under shop counter, you will find assign merchants. Now if you press on add, you will see the pin is exposed, and now you can use this selector and select this James character. Okay, so now it's saved. But now the problem here is that you are picking up the James character. Okay, you are not picking the merchant component, because entire logic that is connected with the merchant trading and everything is stored in this component. So that means we cannot just store the merchants. So what we will do, we will create a struct. Don't worry, I will explain you this weak object pointer, but first I need to set up the situation for you. So we'll say struct f merchant entry. Okay, and this struct should be available in blueprint. So we'll say blueprint type, and let's also write generated body because it's going to be in blueprints. And now first we will take the merchant from the level editor. So what we will do, it's a pointer, weak object pointer of actor class, and we will say merchant. Okay, and it's a variable which is exposed in level editor, so we will copy here. And now once you put the merchant actor via level editor, and then we will play the game. So at the event begin play, we will extract that merchant component. It's a u merchant component. Okay, this is the actor component that we created right here, and we are going to say merchant component, and we are going to initialize it with null pointer, and this merchant will be initialized in the level editor. So we are leaving this as is. Now thing is, we have to include this class. and we want to tell Unreal that this class exists. Don't include its header file because we do not want anything from inside. Just believe that it exists. Okay, and the error is gone. Great. Now what you can do, instead of storing weak object pointer in the assigned merchant, you will take this merchant entry. All right. Let's go and hit live coding again. All right. So select the shop counter and let's delete this, add it again, and you will find merchant field or the variable option right here. And you can select it via the picker. So you got the James character here. Awesome. Now at the event begin play, we would like to fetch the components of each merchant that has been assigned in the level editor. So we will go in shop counter.cpp and here we will run the loop. So we are going to iterate over the merchants, assigned merchants, and it is of type f merchant entry and reference. We are not duplicating it, okay? We are taking the reference as it is so that we can update it without creating the copy. So we will call it entry and put curly braces. Okay, now if you are following me in the C++ part of the series, like last inventory system, what we used to do was we used to check like this by placing exclamation mark entry dot merchant, and if it is not valid, then continue. Okay, it's okay, ignore the warning. I'm just telling you what you used to do and how the weak object pointer is different. And now here I would have done entry dot merchant, because if it was not valid, then it would have gone to the next entry. But if it is valid, then it will go further. Merchant is a pointer according to you. So you use arrow, and then you would have used get component by class. And the component that you're looking for is merchant component, and we need to include its header file now. So we will say hashtag include merchant component.h because they are part of the same directory, and I would have got the merchant component, and this would have given me the pointer to that merchant component because it's a object again. So I would have said merchant component pointer, and we would have said merchant component. Okay, and if merchant component, or let's just say component, if merchant component is valid, then in that case I would have done entry dot merchant component and we would have said comp. Now this would have been your usual attempt with the pointers. Now let's understand the problems here. If you do entry dot merchant, if you would have kept it like a normal pointer, you would have kept it like this. If I remove it for a second, don't do it, just watch me now. If you would have done it like this, then it could have been a problem for you. And let me explain how exactly. This entry dot merchant, when your merchant dies, when your character dies, this pointer will not become null. Now let me show you how it is working out. Let's say this is your merchant, okay? This is your player and it is James, okay? And now you are having your normal pointer. So if you would have gone with normal pointer, let's say the pointer is at 4000 and it is pointing to 3000, okay? So let's say if the character is dead, then this particular memory block is gone, okay? But your pointer is still pointing to 3000, hoping that you will get the data. And pointer is storing the address of the data. So even if your character data is destroyed once it dies, this memory block is still valid. So this check would have passed successfully. Okay. Now remember, your data is gone here. Okay. But the address, the memory block is still valid. So this will continue. And now it will make an attempt to access this data and get the merchant component. Now this is the place where your editor would have crashed or your game would have crashed, because your pointer says I am valid, but your data says I'm destroyed. So in that situation, this check cannot help you. So for that situation, we have to stick to weak object pointer. Now how you will use a weak object pointer here is by using entry dot merchant dot is valid. Okay. This will tell you whether the data is valid or not. So this check will run successfully. Okay, so if it is not valid, then continue. But if it is valid, then come here. So this entry dot merchant will be a valid data at this moment. This is what the weak object pointer solves. Now, many of you who have been following the series, especially the inventory item, you will recall that when you were creating item definitions, I was asking you to use object pointer. Why I did not use the weak object pointer then? What is the difference between normal pointer, weak object pointer, and the object pointer? So now it's a very good time to understand the real significant difference. So let's first go to shop counter. You are storing the normal pointer. This is called raw pointer, which is the fastest way. Then there is a weak object pointer, and then there is a object pointer. So you understood how this pointer and weak object pointer is different. This pointer will not know whether the data is dead or not. This weak object pointer will allow you to perform that data check. Now, when it comes to the object pointer and weak object pointer, it's about ownership now. So when you do object pointer, this means whatever fragment are created in this particular item definition is owned by this particular item that you are going to create. So let's say if you created a rifle object, okay, you created a rifle item, you have the name, you have all the fragments. Like if I go here and go to inventory system v2, you have the rifle definition. Now observe, the name and all the fragments that you created belong to this particular instance, belong to this particular object that you have created. In case of weak object pointer, you say, I do not want to own this. I just want to keep it and let me know if it destroyed. Okay. I just want that safety check with me. So the merchant component is part of the James character. So it's the James character who owns the merchant component. Okay. So weak object pointer says, I don't want to own his component. I just want his component so that I can do my stuff that is involved in the trading. Okay. So object pointer means you own it. That means if you are not destroyed, the component will not be destroyed. Here what is happening, this merchant component is owned by the character. So if the character dies, all these components will die too. But if you would have used the object pointer, then if your merchant dies, the components will still live in the memory. Why? Because it's not the James character that hold the merchant component. It's your shop counter that owns the merchant component. So it's about ownership. It's about garbage collection. It's about how to free the memory. Because when the James character dies, I want all of its components to be gone. So I want the ownership to stay with James because I need to get my data cleaned up if the James character dies. So that's why we said we do not want the fast pointer because we have a situation where he can die. And we also do not want object pointer because we want the cleanup to be handled by the James character. So we said give us the weak object pointer so that we are in the safe side. That's it. That's the difference between object pointer, weak object pointer, and the raw pointer. Now this is the fastest. Okay, so this is very subtle detail and you should pay attention to it. In blueprints, you cannot think about all these things. Great. So what we are saying, we will get the component and then it's a reference. So whatever we will update here will be updated in the entry or in the assigned merchants as well. But now thing is you cannot access the entry.merchant like the normal pointer because this is now a weak object pointer. So we have to first of all get the merchant data so that we can use this arrow. So what we will say entry.merchant.get. This will get you the data or the pointer. And we will say pointer to an actor and we will say actor. Okay. And now here you will do actor pointer get component by class and then you will get the merchant component. Now if that component is valid, then you add it. So once this is done, we will go to merchant component and we will create a private variable that will represent whether the merchant is available or not. So boolean b is available. So I will set its value by default to true because initially the merchant will be available. And we will create public getters and setters. So let's write C++ only, getters and setters. because tomorrow you can change this. Bool, and I'll say is available. So this is the function that I will call from the shop counter, and I will return B is available. Okay. And I will say set availability. Okay. And we will take input. So, and I'll say B is available to in new state. Oh, sorry, Python side effects. Okay. So you got your getter that will get this value and the setter that will set this value. And now let's go back. So now what I'm going to do is I will bring my another AI character that is under AI character SWAT soldier. And I will create a state tree. Okay, so let's create a state tree that will drive him to this shop. So I'll create a state tree and it's a state tree AI component schema. I'll select this st interact with environment. Okay, I'll open this up. And now here you have the AI controller class, which is AIC default, context actor BP AI default. Okay, cool. So if this tree is in action, then first of all, I'll say search. Okay. So this is state that represents search the smart objects. I'll add one more state inside it, drag it, and this state name is find smart object. So the character is in the search state. So first goal is to find the smart object. Then the second, after you find the smart object, you are going to interact with the smart object. Okay, and you can add colors. So like in colors, I can go for search and I can make it like orange. Okay, so this is a search state and you will do these two tasks. Now let's see how you find the smart object. I will create a task. So you need to provide a task. I will create one. We have the state 3's task here, so I'll paste it here only. STT state 3 task, find smart object. Be really precise. There you go. And you will go for enter state. So as soon as the state which contains this task is active, we will start the work. Now, how do we find the smart objects? So there is a subsystem that runs continuously in the background when you start the game. So you can search for subsystems and you can see there are a lot of subsystems that are running behind. What do we want is the smart object subsystem. So I'll search for smart object subsystem. Okay. So this subsystem is like a service that will deal with your queries or any kind of functionalities or queries that you want to do with the smart objects. Okay. So we'll say to this subsystem, I want to get the smart objects in the world. Remember, subsystem means that runs in the game for everyone. It's like a brain of your game world. So the game world has different set of services and subsystems which serves you different functionalities, and this subsystem is going to give you the smart object related information. So I'll request this service to find the smart objects. Now, when you want to find the smart objects, you have to provide the request. So what I'll do, I'll say make smart object request. So here you have to provide these two constraints. Okay, we will give you the smart objects, but first of all, tell us what is the range that you are looking for in what area, and then are there any filters that you want to attach? That is the request. And you also have to tell them for which AI character you are running this. Okay, so we need the character. So I'll promote this to variable and I will say character and I'll get this connected. Sorry, let me delete it. And this will come from context. Remember, the AI context actor class is there, so we want to take it from the context. That's why I gave this category. If you are new to state trees, then please check out the episodes. I have pinned them in the cards to understand how the state tree works. Now, first of all, you have to tell the range in which you are doing this. So what we are going to do, we are going to say, get us the character and get the actual location. So this will give you the center and we'll go for make box with origin. So this actor, which is our character, the SWAT soldier, we will consider its center as the origin, and we will promote this to variable and search extent, and we will make it input category, and I'm going to compile it. And in the default, I will say let's scan around 1000 by 1000. Okay, and let's assume the height of 100. Okay, so this is our query box. And are there any filters? Now this is where you will use the tags. Remember, in the smart object I asked you to assign the tags. Let's go there in the architecture, wooden shop table. You see merchant slot. If you want this, then this is the filter. Only the person with this tag can access it. Or customer, this particular slot is reserved for these two tags. So we will use that filter here. So we will say this is our customer. So I will say NPC. Okay, I'm an NPC. So find me the slots that are available for this particular tag. Now this is going to give you the list of smart objects that are around this area and which satisfy your NPC filter. And there are more details like activity requirements. You can add that. Should you include the claim slot? See, once a NPC take this slot, this will be reserved. So we do not want to consider that in our search, because if a smart object is occupied with something, with someone, then we do not want to go there. So we will not mark it true, because we do not want to go to a place which is reserved. And we also don't want the disabled slot. Let's say your merchant shop is damaged. If you are building that kind of game where construction plays a big role, then in that situation your building might be down for maintenance. Then in that case, disabled slot will help you a lot. So that is the situation. So we are not going into that right now. We are going simple, then we will extend as per the situations. So once you got the smart object, you want to save its result. So you'll save it in out results. Okay, and let's put them in a function. So I'll select all of them and right click collapse to function, and I'll say find nearby smart objects. So we can open it up and we are going to return the result, whether the smart objects exist or not, which we have saved in this array. Great, so you got the smart objects. Now first of all, we will check if there are any smart objects or not. If they do not exist, then finish the task. That means we did not find anything, so succeeded to false. But let's say if you did find, then what we will do, we will say find the nearest smart object. Because there are a lot of smart objects coming, we will just say find the nearest one. So we'll create another function, find nearest smart object. So first of all, you get the character's actor location, because we want to do the distance comparison, and promote this to a local variable, and we will say character location. Plug this here. Then we go for a sequence spin, and we will say for each loop with break. That means we will find the nearest item, and we will take the out results that are being calculated. And now we will get our subsystem of smart object, and we will say get smart object component by request result. So what this is going to do, this out result that you just got, or the array, you will iterate one by one, and you will take that result and you will get the smart object component that is present in the wooden shop table smart object. So this will give you the smart object component, and we want to get its owner. So get its owner meaning I want the wooden shop table. Once I get that actor, now I can do the distance comparison. So I'll say get this actor's location and subtract it from my character's location to get the distance. And I'll do the vector length here. And I'll say less than, promote this one to a local variable, and I will say minimum distance. Okay, and by default I will assume it very high, like triple, or let's say 4 times 9. So we want to get the nearest item. So first we will check if it is less than, that means you found a slot whose distance is less than the current distance. That means it is more nearer to what you had earlier. So if that is true, let's make it less than equal to. So we'll say if it is true, then update the minimum distance. Okay, and the minimum distance is this one. Now this is the nearest item. But let's say if you found an actor that is greater, that is far from the previous one, then in that case I would like to break. Let's first of all connect this. And okay, so this will stop the loop, and once the loop is stopped, we will return whatever actor was nearest. So we will save its index every time when we find the nearest item. So I'll say item or smart object index. So we'll say integer, and the index you can get it from here. Update it only when the distance of this actor is less than from the previous one. And when the loop is over, I would like to return this index. And I'll say smart object index. Compile, save all, go to event graph, and I'll call this find nearest smart object. Now this will tell you. So what we'll say, okay, we found the nearest item. Let's check if it is valid or not. If it is a valid index, then we would like to proceed. Otherwise, we will say finish task. We did not find it. So let's duplicate and set it to false. And we will get a copy of this smart object index. And now we will store it in the tree so that interaction task can use it. I'll create a parameters here and I'll name it smart object or selected smart object. Okay, and I'll change this to smart object request result. Okay, so compile, save all. Why I did that is because this is of type smart object request result structure. But now the problem is you cannot update the variable like that. So remember I told you you have to use references. So I am going to create a variable. First of all, let's compile. I'll say selected smart object ref. So we are taking the reference of this variable so that we can update it from here. So I'll say it's a state3 property and it's a reference of it. So first of all, first you get the property reference. Let's compile and select this and change this to smart object query request result, because that is the type of variable that we'll be plugging. So we will say get us the property reference, which is where it is pointing to, and then set the value over there. So what value are you trying to set? This result that we found. And if it fails, that means that variable does not exist, so we cannot proceed. But if it is successful, then in that case, I can make it succeeded. Save all. All right, so this gives you the smart object, and now let's make it part of the input. So compile, save, go back, and now you can plug your task here in the find a smart object. You can plug your actor, you can plug the parameter smart object, it automatically detected. What I can do is go for parameters and then I will bind it. Okay, so now compile and save all. Great. So if you found the smart object, you will get a successful state selection. So we'll go on state succeeded and transition to interact with smart object. Otherwise, if it failed, then tree failed. That means you wanted us to interact with the environment and we failed to do that because we did not find any smart object. So do something, go somewhere else, go to that location where there's more space, but that is not the job of this tree. So we are saying state failed, tree failed. The tree is done. So when it comes to interact with the smart object, we will create another task and we'll say STT interact with smart object. Let's make it full. Okay. So now here's the thing. You detected the smart object right here. Okay. It was the result structure. Now how to interact will be told by the shop counter, which is the smart object, based on the slot you take. So if you are a customer, then you will follow the customer trading behavior. If you are a merchant, you will follow the merchant based interaction or behavior. But the idea is you just go and claim your space and then the smart object will tell you how to interact with it. So this task of interact with smart object is generalized. You can use it for any smart object. Does not matter if it's a shop counter, if it's a gun, if it's a bike, if it's a vehicle, and whatever the interaction is, that will be told by the smart object. So what I'll say, I need the smart object first. So I have to get that value from this variable. So I will say smart object request result. Okay. And I'll say smart object request result. Get me this, and I will make it to the input category. Now, if you save and go back to interact with environment and you add this task here, you can bind this property. Okay, let's go back. So you got the smart object request, but you want to access the slot. So what you will do, you will break it, and this will give you the slot. Okay, so it is giving you the smart object handle, and it is also giving the slot that you have to claim as an NPC based on the request query you did. So we will say that my NPC is going to claim this slot. So mark this smart object slot as claimed. So who is claiming it? Give us the user actor. So we'll say, okay, I'll give it to you. Character, actor, object reference, and this is the person who is claiming it. Now, once you claimed it, the smart object will keep it occupied. No other NPC will be able to take your slot. Now, you have to move to that slot so that you can begin the interaction. Remember, if you want to sit on the bench, we used to first take you to the position to sit, to make you sit. So that's what Unreal Engine is also going to give us. So we will say move to it from here, move to smart object, and with gameplay interaction, because we are using the state tree. We'll do this, and now it needs the controller. So what you will do, you will get controller of this AI character. So get the AI controller and you will pass it. Remember, it only works for AI, not for a player. I'll tell you how to do for player. Okay, once you reach there, you will finish this task. So finish task. And if you failed and you are not able to move, then we will say false. Compile, save all. Okay, as soon as you reach there, that tree will be injected in your AI controller. Remember, in the AI state trees, you have this AIC default, and right now you have the travel behavior. The smart object will replace it and inject this particular state tree which you got from that selected slot. Okay, and we will go back to our interact with environment and we'll say if this task was successful, then tree succeeded. That means the objective was to interact with the smart object. Now interaction will carry on, but interaction has begun. So we'll say this tree succeeded. But if this failed, that means we were not able to do it. So tree failed. Okay, so compile, save all. So that's how your customer will go to that place. So let's test it out for our SWAT soldier, and we also need to assign animation blueprint to the James character. So I'll go here and select our ABP base. Okay, save and compile. And now I'll go inside my SWAT soldier, and first of all I need to get my AI controller, and I'll pass the reference to self. So the AI controller that is there, get it, and I will get the brain component which will give you access to the state tree as well, and I will start the logic. Okay, so we'll connect it in the event begin play. Cool. So compile, save all, and let's place your character a little far. And let's also add the nav mesh bound volume so that our AI characters can walk. I think it is in here, nav mesh bounds volume. Okay, and I will scale it down. And let's play. We forgot to plug the interact with environment into our travel behavior. So if your travel mode is escort, go for escort. If it's follow, go for follow. Otherwise, you just live your life, that is interact with the world. So I'll say interact with environment. And this will only happen if these two are false. So I'll link the state tree. So linked asset and interact with environment. So this is how I keep things decoupled. Save and let's try again. Okay, it did not work. Let's see. I'll go to travel debugger. No, it did work. It went to find smart object. Okay, it is working. So let's see what is going wrong here. I'll go in the interact with environment and we go in search, you go and find smart object. To debug is that we go in the task. Now you see you are finding the nearest smart object with this query. So let's see whether the box is able to capture the shop. So what I'll do, I'll show draw debug box and it will draw this exact box in the game so that we can see if the query is going right or not. So this is the center, this is the extent, and then the line color, let's change it to red, and duration, let's increase it to 22 seconds, thickness 4. I will save and compile, play again. Okay, you see this box? So this is around the character. Okay, so it did enter in the interact with smart object, but it was not able to interact with that. So why is that? Let's check. Oh, we did not made the binding for character. So let's make it context. Save, compile, go back to environment and bind it to the actor. Now it will work. Okay, you see the slot is occupied. So that's it for this video. I hope you enjoyed it. Do let me know if you have any doubts, queries, suggestions, feedback, questions in the YouTube comment section. And the Discord is always open for you. You can share your screenshots and whatever problems you have got, you can discuss over there. All the assets that are used in this series are available free over there. And in the next episode, we will create the logic of raising a trade request, then merchant being assigned, and then giving you the required item. So we'll do that in the next episode. So stay tuned. And if you like my work and you want to support me, the Patreon and the coffee link is in the description. We support both one time and membership option. Just talk to me before buying any membership. So I will see you in the next video. Till then, take care. Bye bye.